Then the girl in the corner with the scarlet letter. While you're watching, you may think that she doesn't matter, but no one knows you better.
So, hi guys, I'm Jubeloria and I'm here to answer all the activities in Chapter 6. Chapter 6 Network Layer. Network application and services on one end devices can communicate with applications and service running on another end device. How is this data communicated across the network in an efficient way? The protocols of the OSI model network layer specify addressing and process that enables transport layer data to be packaged and transported. The data network layer encapsulation enables data to be passed to a destination within a network or on another network with minimum overhead. This chapter focuses on the role of the network layer. It examines how it divides network into groups of hosts to manage the flow of data packets within a network. It also covers how communication between networks is facilitated. This communication between networks is called routing. So let's proceed in the activity of chapter 6. The first activity is the IP characteristics. Instructions. Read each IP characteristics, then click connectionless, best effort or media independent to indicate its delivery method. So this is the IP characteristic and we can click the connectionless to the delivery method to its function. First is the packet delivery is not guaranteed. I think this is the best effort. Next is fiber optics, cabling, satellites, and wireless can all be used to route the same packet. I think this is in the media independent. Will adjust the size of the packet sent depending on what type of network access will be used. I think it will be on the media independent. Does not guarantee that the packet will be delivered fully without errors. I think is the best effort. Will send a packet even if the destination host is not able to receive it. In the connectionless and last, the no contact is made with the destination host before sending a packet. In the connectionless. So congratulations, you have matched the IP characteristic to their delivery methods. Next next activity is the part 1 IPv4 header fields instruction. Read each IPv4 header functions and then click the IPv4 header field to which it belongs. This is the IPv4 header functions and this is the IP header fields, the version, the differentiate services, the time to leave, the protocol, the source IP address, the destination IP address. First, commonly referred to as hop count. I think time to leave identifies the priority of each packet. The differentiated service identifies the upper layer protocol to be used next. Um, this is on the protocol. Identifies the IP address of sending host. The destination IP address. The source IP address always set to 0100 for IPv4 the version, and identifies the IP address of the recipient host, the destination IP address. So that's all correct. Congratulations, you have matched the IPv4 header functions to their fields. Mm, and next activity is the activity IPv6 header fields. So instruction: read each IPv6 header description and then click the IPv6 header field to which it belongs. This is the IPv4 header descriptions, the IPv4 header fields, the version, the payload length, the traffic class, the next header, the flow label, and the hope limit. So to suggest that all packets receive the same type of handling by IPv6 routers, flow label identifies the size of the data portion of the packet, mm, and the payload length. When this value reaches 0, the sender is notified that the packet was not delivered. In hope limit and classifies packet for congestion control. Time class identifier identifies the application types to the upper layer protocol and the next header, and is always set to 0110 in version. So congratulations, you have matched the IPv6 header description to their fields. Next activity is the activity identify elements of a router routing table entry. Instructions: a partial router routing table entry is shown. Each section of the entry is identified by a circle letter above it. Select the correct routing table entry section for each output. So we choose between A, B, C, D, E, and F. Number 1. The elapsed time since the network was discovered. The answer for letter A, D. For B, 192.168.1.0 24. For letter C, the 90 over 3072, and for D via 192.168.3.1, and E 000603 on a F gigabyte Ethernet 0 over 0. I think it's in E 0603 because the elapsed time. So next is the administrative distance source and metric to reach the remote network. I think the letter C. How the network was learned by the router. I think letter D. Letter A or D. Show the destination network. I think letter B, because 192.168.1 is the number for the network, and next is the next hope IP address to reach the remote network is letter D, and last the outgoing interface on the router to reach the destination network. I think letter F. So let's check. You have successfully chosen the correct router. Routing entry is described. For next chapter, for next activity, the activity description of router function and hardware parts. Description of router functions and hardware parts are provided in the table. Drag each router component name to its function or description. So we need to drag this to their corresponding description. Number one, connects router to external networks, usually over a large distance. I think the answer is one, interface, a way to remotely access the CLI across a network interface. I think the Telnet or SSH connects computer switch and routers for internal networking. I think LAN interface, a local port which uses USB or low-speed serial connection to manage network device. I think console port, a port to manage routers using telephone lines and modems. I think AUX port. So let's check if correct. So you have successfully matched the route components names to their function descriptions. Um, the last activity is the router boot process. Instruction: drag each of the steps on the left to appropriate field in the table, on the right to show the router boot process order. The router boot process. So we need to drag all of this step by step to router boot process. So I think the first step is the mm, perform pulse hardware check performed by built-in room chip. I, I think the step 2 is the load bootstrap copied from room to RAM, locate the iOS, and the step 3 is the load iOS operating system for the router loaded into RAM. After Bootstrap finds the iOS file to be used, and last, the step 4 is to load the configuration file from flash NVRAM, a TFTF server, or go into setup mode to create a configuration file. So you have correctly listed the order of the router boots process. So that's all the activities in chapter 5. So the next is the summary of chapter 5. The summary of the summary of chapter 6, rather. Chapter 6, network layer. The network layer or OSI layer 3 provides service to allow end device to exchange data across the network. To accomplish this end-to-end transport, the network layer uses four basic processes: IP addressing for end devices, the encapsulation and the routing, and de-encapsulation. Um, the internet is the larger based on IPv4, which is still the most widely used network layer. An IPv4 packets contain has a limited number of unique public IP addresses available. In addition, hierarchy addressing the network layer is responsible for routing. So that's all, guys. The activities in chapter 6, which is the IP characteristics, the IPv4 header fields, the IPv6 header fields, the identify elements of a router routing table entry, the descriptions of router functions and hardware parts, and the router boot process,